Hello guys, welcome back to the course. In this video, we are going to track and monitor machine learning model performance using MLflow. Okay, let's get started. Firstly, let's create a new folder. I'm going to name the folder MLflow. You can name it whatever you want, it is totally up to you. And let's open VS Code. And we are going to open the folder. Let's click open. Next, we are going to create a new file. So let's click this. I'm going to name the file tracking model performance.py. And I'm going to save this file inside the folder. Let's click create file. Okay, now we are going to install MLflow. So let's open a new terminal. I'm going to copy and paste this. Pip install MLflow. Okay, now we are installing MLflow. It will take few seconds, maybe 10 seconds. Okay, now I'm going to clear the terminal. Next, we are going to import several Python libraries. Firstly, we are going to import pandas. We are going to use this library to load the dataset. Next, we are going to import MLflow. We are going to use this library for experiment tracking and logging. Then after that, we are going to import MLflow scikit-learn module. Next, we are going to import train test split. From scikit-learn.model selections, import trained test split. We are going to use this library for splitting datasets into training and testing sets. Next, we are going to import label encoder. From scikit-learn.preprocessing, import label encoder. Make sure it is uppercase. We are going to use this library for converting categorical labels into numerical format. Next, we are going to import random forest classifier. From scikit-learn.ensemble, import random forest classifier. So this is the machine learning model that we are going to use. Next, we are going to import accuracy score, precision score, recall score, F1 score, and confusion matrix. From scikit-learn.matrix, import accuracy score, precision score, recall score, what else? F1 score, and the last one is confusion matrix. Okay, next we are going to load the datasets using pandas. Let's create a new variable. I'm going to name it data. And to load the datasets, we are going to use pd.ratecsv. Next, we are going to get the file path. So let's open the terminal. And I'm going to drag these datasets to the terminal. And let's copy and paste the file path. And let's go back to VS Code. And let's put the file path inside the parentheses. Make sure there is no space. Just in case you forgot, the datasets that we are using is earthquake alert predictions datasets. So just download from this page. Just click this download dataset as zip. Okay, let's continue. Now we are going to copy and paste some of the codes from Google Colab. So let's open this file, building earthquake detections model with random forest classifier. And we're going to copy and paste these codes. And let's go back to VS Code. Just a quick reminder, we define the features and also target variables. In this case, we have 5 features: magnitude, depth, CDI, MMI, and significance score. And the target variable is alert. Then after that, we're using label encoder to convert the categorical columns into numerical format, and we also use train test split To split the datasets into training and testing sets, 80% of the data will be used for training and 20% of the data will be used for testing. Okay, let's continue. Now we are going to set MLflow experiment name for organized tracking. We are going to use this library. Let's copy and paste this, MLflow.setExperiment. And I'm going to name the experiment Earthquake Alert Tracking. You can name it whatever you want, it is totally up to you. Next, we are going to start a new MLflow run sessions for tracking with MLflow.startRun, and we are going to set the run name to RF trained eval or evaluations. Okay, now we are going to initialize random forest classifier model. Let's create a new variable. I'm going to name it RF model, and we are going to copy and paste random forest classifier, and let's put it here. We are going to set the n estimators to 100. Next, we are going to set the max depth to 8. And lastly, we are going to set the random state to 42. Next, we are going to train the random forest model using the training data. RF model.fit. And let's copy and paste x trained, and let's put it inside the parentheses. Let's copy and paste y trained, and let's put it inside the parentheses. Next, we are going to predict labels on the test datasets. Let's create a new variable. I'm going to name it ypred, and we are going to use the RF model again. So let's copy and paste that, RF model.predict, and let's put xtest inside the parentheses. Next, we are going to calculate the model accuracy score. Let's create a new variable. I'm going to name it ACC. It stands for accuracy. And we're going to utilize this library, accuracy score. Let's copy and paste that. And let's put ytest and ypred inside the parentheses. Let's copy and paste this and put it here. And let's copy and paste ypred. And let's put it here inside the parentheses. Next, we are going to calculate the micro average precision score. Let's create another variable. I'm going to name it precisions, and we are going to utilize this library, precision score. Let's copy and paste that, and let's copy and paste ytest and ypred, and let's put them inside the parentheses, and we are going to set the average to macro. Next, we are going to calculate the micro average recall score. Let's create a new variable. I'm going to name it rec, and we're going to use the recall score library. And let's copy and paste this, ytest, ypred, and average macro, and let's put them inside the parentheses. Next, we are going to calculate the micro average F1 score. Let's create a new variable. I'm going to name it F1, and we are going to use this library, F1 score. And let's copy and paste this, ytest, ypred, and average macro, and let's put them inside the parentheses. Next, we are going to generate confusion matrix. Let's create a new variable. I'm going to name it CM. CM stands for confusion matrix. And let's copy and paste this library, confusion matrix, and let's put ytest and ypred inside the parentheses. Next, we are going to log model parameter number of estimator. MLflow.logparam. Let's copy and paste n estimators, and let's put it inside the parentheses, and in this case we set the n estimators to 100, so let's put 100 inside the parentheses. Next, we are going to log model parameter maximum depth, MLflow dot log param, and let's copy and paste max depth, and let's put it inside the parentheses. In this case, we set the maximum depth to 8, so let's put 8 inside the parentheses. Next, we are going to log model accuracy metric. MLflow dot log metric, and inside the parentheses, let's put accuracy, and let's copy and paste this variable ACC, and let's put it here. Next, we are going to log model precision metrics. You can copy and paste this line, guys, because it is going to be the same, but we're going to replace accuracy with precisions. And we are going to replace ACC with prect. So let's copy and paste this variable and put it here inside the parentheses. Next, we are going to log the model recall metrics. You can copy and paste this line. And we are going to replace precisions with recall. And let's replace prect with rect. Next, we are going to log model F1 score metrics. Let's copy and paste this line again. And we are going to replace precisions with F1 score. And let's replace prect with F1. Next, we are going to log trained random forest model into MLflow. In this case, we are going to use MLflow.sklearned.log model, and let's copy and paste RF model and put it inside the parentheses, comma, and let's put model here inside the parentheses. Next, we are going to print a confirmation message to let user know that the model training is finished. Print model training and evaluations complete. Then after that, we are going to print the formatted model performance metrics. We are going to print the accuracy score. Let's copy and paste this variable ACC, and let's put it here. And we are going to round this up to 3 decimal. Next, we are going to print the precision score. Let's copy and paste this prect, and let's put it here. And we are going to do the same thing. We are going to round this up to 3 decimal. Next, we are going to print the recall score. Let's copy and paste this right, and let's put it here. And we are going to do the same thing, guys. We are going to round this up to 3 decimal. Next, we are going to print the F1 score. Let's copy and paste this and put it here. And we are going to round this up to 3 decimal. Next, we are going to print label for confusion matrix display. Confusion matrix. And don't forget to print this variable CM. Let's copy and paste that and put it here. And lastly, we are going to print a message confirming the model is tracked in MLflow. /end model logged in MLflow under experiment, and let's copy and paste earthquake alert tracking, and let's put it here. Okay guys, we are done. Let's save the file. Just click file and click save. Okay, now we are going to compile the code. Let's open a new terminal. And firstly, I'm going to clear the terminal. Next, we are going to access the project folder. So let's type in cd user/ChrisAldica, that's my username, /desktop/MLflow, that's the project folder. Next, we are going to type in Python tracking model performance.py, that's the file name. Okay, just wait guys, it will take few seconds, maybe 5 or 10 seconds. Okay, here we go. Model training and evaluation complete. The accuracy score is 0.912, the precision score is 0.911, the recall score is 0.913, and the F1 score is 0.911. So the performance is pretty good. And here is the confusion matrix. Okay, next we are going to add 2 more lines. Let's type in from MLflow .server import app.run host. We are going to set the host to 127.0.0.1. Next, we are going to set the port to 5001, and we are going to recompile the code. Let's type in Python tracking model performance.py. Okay, just wait guys, it will take few seconds. Okay, now we are going to copy and paste this link. So let's open Google Chrome. You can use any browser that you want, it is totally up to you. Okay, here is the MLflow dashboard, and let's click this earthquake alert tracking. Okay, here we go. We have just trained the model 19 seconds ago, and you can click this and you will be redirected to this page, and you can scroll down and you can see the accuracy score, recall score, precision score, and F1 score. So this is the dashboard that you can use to track and monitor the performance of your machine learning model. Okay guys, I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.